Okay. Yeah. Let's start with this time series. We discussed about this time series analysis in the last class. See, till now we completed about, first one is about, we started with the mean and central tendency related things, mean. And from then we went to the variance and to the standard deviation. And then next one after the higher level is the correlation. And after correlation, we went to the regression analysis. And after the regression analysis, in that different types, we have seen that. And now another, these are all the analysis parts. Actually, how to analyze the data. These are all the things that kind of a tools that for the analysis of the data. Now, sir, why we are using these many tools? Why not one or two? Why don't we go with mean and other standard deviation and other things? We have seen that, right? Mean, it has its own disadvantages. Standard deviation, it has its own disadvantages. Like we cannot, apply the same analysis part for all the types of data actually. Okay, this is the problem with that. That is why, based on the type of data, based on the type of variables that you are taking, say all the time it won't be happen with the same variables. Let us say the season and the diseases which are occurring, right? Okay, in the rainy season, these viral fevers are more. Let us say, is the only the rainy season is the independent variable, or the diseases are the dependent variable? When you take any two variables like this, you cannot show that only because of the season fevers are coming, right? Let us say fever, viral fever or diseases. And if you take that two variables, can you agree with that? Because of the season, viral fevers are coming or diseases are coming. Is it the correct dependent variable for this variable?
Sir.
Yes, no?
Yes, sir.
Yeah. Yes, correct only. But it is only not about the season the way these are coming, right? There may be different hygienic related things and other history things. There are different other variables also. Variables means different other factors also will be contributing for the diseases. So the main thing may be the seasons, but how the season is affecting the diseases, I mean, the number of diseases recorded or number of, let us say, viral fevers recorded, etc. Whatever, there may be different reasons, right? Yeah, see, that is one thing. And let us say now crops. Again, it is dependent on the seasons or a period of time the crops will be grown. Okay. And another thing that when demand is more, in some seasons the demand will be more. Ice creams, in which season demand will be more? Summer, right? When in the hot season, the demand will be more for that. And you can't apply for the season and every season to the ice cream sales. Okay. See, like that, when we think about the different aspects in the time series, see, over a period of time, let's go into this. Already we have seen the definition. A time series may be defined as a sequence of repeated measurements of a variable. I think by this time you would understand what is variable means, right? Made periodically through time. Variable means anything, any factor that we will be taking. It may be the diseases, or it may be the sales, or it may be the health conditions and activity, output, whatever. People are satisfied. Jobs, employee satisfaction based on the salary. Is the salary is the variable? Salary variable. Employee satisfaction. Salaries increases. It may not be the salary, right? There are different other aspects. What are the variables that you're taking? And see, and this measuring, see this, please see this sequence of repeated measurements of a variable, one variable, made periodically through a time. Now, see, a time series may be defined as sequence of values of some variable, corresponding to the successive points in time. and collection of readings belonging in different time periods. Different. See, I cannot tell the same answer all the time. How are you now today? Maybe the people who are having some kind of diseases like arthritis and so on. For them, generally winter is a enemy season for them. And with winter, the arthritis, the pains will increase actually. Okay. So, but in the season and different seasons also based on different factors also the pain or the sufferings that they're suffering will be high or low. Right, that is what when you are taking those readings, the timings in a series of things, then we call it as a time series analysis. And how to analyze the time. So, what is the use of this? Because last year in summer season the sales are this, and based on it, okay, in winter season the ice cream sales are coming down. Summer season ice cream sales are going up in a time series, in a seasonal series, and in the next year, what will happen? Okay, let us produce less ice creams in the winter. Let us produce more ice creams in the summer. Past data. Okay, let's go into the important part. Now, objectives, we know that I'm not going into the theoretical part more today. And of course, we need to understand few things in order to understand the sums as well. See, when you're going to understand the sums, try to read once. Maybe you may be understanding or not, but based on the basic things I am giving, you will try to understand this content as well. Okay, I think you got some understanding about variable. You got some understanding about what is time series and the sequence and this. Those words will be there here, and you're studying. So to study the past behavior of the data, to make forecast of the future. This is what we discussed till now, right? You study once before you understanding the sums and this. Anyway, you have this textbook. Right, time series is applied to forecast the future. This is the thing. It will apply to forecast the future. When you are forecasting the future, it will apply. By analyzing the past behavior of the variable under study, we can forecast the future. Past behavior, how it is, how the sales are. Sales are my variable. Just please keep this point in your mind. Past sales are high in some certain situation. Now this in the future, it will be there. I'm estimating that. Time series is also used to evaluate the past performance. This is the important words. Okay, right. It helps in understanding past behavior, evaluating current operation, for planning future operation, for comparative analysis, one period to another period, taking scientific decisions. And these are important things where we will use these time series analysis: economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield projections, process and quality control, inventory studies, workload projections. Last time we have given this workload, output is good. Let us also go with that. Census analysis. Census means the population, how much it is, right? These are the things. Now, there are some components in this, 4 basic components: secular trends, seasonal variations, cyclical variations, and irregular season. What is secular trend? Refers to long-term variation, whether the variable trends increase or decrease over a period of time. This is the secular trend, right? See, the steady increase in the cost of living index recorded by the consumer price index is an example of secular trend. Cost of living is increased. Cost of living is recorded. And how is the consumer price, right? And say, how we will define cost of living? Hello? What is cost of living means? Everybody is quiet. Can someone answer?
Depending on the place, I think increase price or place, everything, living.
Very good. Good. That is good. Depend on the price. Let us say here 4 idlis. If you go to the 5-star, I'm not talking about 5-star. General price, 4 idlis, if you buy in Hyderabad, it is 30 to 35 rupees, right? And if you go to Bangalore, what is the cost of 4 idlis?
Maybe 70 or 90.
See, where is cost of living is high? There or here?
Bangalore.
Of course, Bangalore, right? That is why people will move from there to here. Some people, if you go there, unless you get some double the salary, people won't go there. And here for rent for 2 BHK, we are staying in Sun City. You will get between 12,000, 15,000 like this. And if the same thing, if I go to Yusuf Guda, main center, or Maitrivan, or somewhere where Ambedkar University is there, definitely for single bedroom only, I need to pay 15,000. Cost of living is high there based on the place and this. Now here the point is that the cost of living is based on the consumer price index. This is a secular trend, right? Rising trend. Gradual increase, declining trend refers to the gradual increase over a period of time. Short-term variation does not include as part of secular trend. See, this is a gradual increase. The days to come, that will be go on keeping on this. So that is secular trend. Now coming to the uses of secular trend value is very useful in studying behavioral pattern of the variable. Behavioral pattern. Next, enable us to make comparison between two time series data, because continuously it will change. Here, see long-term changes in productivity, increase in rate of capital formation, growth of population. Will it down? Population will be down or increased? Definitely it will increase. When this trend, secular trend, that will be increased, it won't come down. Technological innovations, it will be increased. Transformation in socio-economic setup, it will be increased. Use of secular trend. The trend values are very useful in studying the behavioral pattern of the variable under the study. Right. Next one, seasonal variation. We know that within a year that trends to be repeated from year to year. Seasonals in in summer season we'll have more production output. The production of mangoes will be more, and of course sales will be high. And if you sell the same mangoes after the summer season and in the winter season, we know that it will, the damages will be there and you won't taste it. And if you are buying this sitafal, this is the right season, right? And after this season, and if you go and buy ice cream in naturals, right? Yeah, natural sitafal ice cream. Oh, you will. The taste is amazing, right? And after that, I think they will only produce the seasonal things. And once the off the season, they won't produce because they want to give the fresh, the content in that. And other people also in non-seasons also they will produce. Okay, that's a different thing, right? Whatever. The time interval of occurrence of seasonal variation vary from a few hours to a few weeks or few months as well. See this? Economic time series are influenced by the seasonal value, that is prices, production, consumption of the commodities, right? See, if the high-priced commodities are sold more, then of course we know that the economic time series, the economy will be grow high, interest rates will be go high. Seasonal variation, periodic and regular. Next one, examples of season: decrease in the farm grains during harvest season. Harvest season, generally we know that price will be there, and even like recently the tomatoes. Right, when the harvest is less and some people lost during the heavy rain seasons, definitely the price of the product will be high. Effect of festival on sale of departmental store. We know that agricultural production, construction material like bricks, cements, etc. All these things will vary all the time, and time to time it will be vary. Next one. And cyclical variations. Let me go into that. Cyclical, sometimes boom and prosperity and depression. Actually, this is recovery, recession, recovery. These phases are not uniform, but their time duration is not fixed. It can be ranged from 3 to 10 years as well. Sometimes it will be when their government is framing some policies, new policies, definitely it will be there. Next one is the irregular variation. See, what my point here is that many of you will be doing the research or project report and this. See, sir, why we are discussing all these things, like if you are doing a research which are relating to these kind of variables, seasonal things and cyclical things and etc., what we discussed about things, definitely you need to think about analyzing the data by this tool, time series analysis. Okay, I think you got this point, right? Hello? Is this clear to everybody?
Yes, sir.
Yeah, based on the data, the analysis part or the tools that we are using will be different. Okay, that keep that point in your mind so that then only you will enjoy the subject. Okay, see, when you're going to, okay, when you're understanding different kinds of analysis parts, oh, this type of all data also there. Okay, this type of thinking also there. Say how the knowledge will increase means this is the thing. When you're studying more, okay, when you're studying about these things, your knowledge will increase. Understanding about the aspects and other aspects also definitely it will increase. Right, that is why we are studying, not for the sake of other things. Of course, that is the thing, and you will use this kind of knowledge in some other company to make the company to grow, or you to start your own business, or doing analysis part and like that, etc. So if you study more on these aspects, you will be an what we call a specialist or expert in that particular subject. Sir, I have this data, please analyze this and give me some information whether I can go ahead with this, because this is the past sales and how to go ahead with that. Okay, I will do the analysis part just by looking. I can't give the suggestions. I require a proof. This is the thing, this is the thing, this is the thing. Right, okay. Decomposition of the trend. The main purpose of the analysis is to estimate and separate the 4 types of variation and to bring the relative impact on each on overall behavior of time series. Analysis of time series consists of 2 major problems: to identify the forces or the influence of the factors which produce the variation in time series. This is one of the big problem. Is that, sir, only the season, or is there any other things which are forcing you to change that particular thing? Cannot tell. To isolate, analyze, and measure the effects of these forces independently by holding other things constant. This is the thing, right? By holding the other things constant, there are 2 models used for decomposition of a time series into various the components. One is additive model. The second one is the multiplicative model. Now, according to the model of the magnitude of time series, YT, at any time, T is the sum of the separate influence of its 4 components. That is T, C, S, R. See this? Trend variations, cyclical variations, seasonal variations, random variations. These 3 are, we know that, trend, cyclical, right? The units of measures are the same for all the 4 components. When the time series data recorded against years, the seasonal component vanish. In that case, YT is equal to this, right? Now, the model assumes that the 4 components of the time series are independent of each other. This is very important. What is independent of each other means which are not depend on any other things. It won't affect any other things. That is independently, it will affecting it. It on its own way, it is affecting the main variable that we are thinking of, right? Those are all independent, has effect on remaining. But in actual practice, this does not hold good, as this factor affect each other as well. Multiplicative model. Decomposition of the time series is done on the assumption that the effects of the 4 components are not independent of each other. Here, separate influence. Here we will this independent of each other. Next, independent of each other, it is non-independent of each other, because one is one, depend on everything. Point of difference between these 2 models. See, in practice, most of the time series related to the field of economics business conform to multiplicate model as the effect of various factors affecting time series not independent of each other. See, multiplicative model will be used because most of the times it will be affecting each and everything, because in academics and business, when the losses are there, it is not only the seasonal effect, it not only the cyclical effect, it not only the trend, sometimes it may not be the random things, but this will be there. Okay, secular trend, historical pattern to project future trend in the pattern, to compare 2 or more things, methods to measure of the trend. Okay, let's go into this. Graphical method, semi-average method, moving averages method, method of least square methods. Graphic method, the simplest method of measuring trend of series. In this method, firstly, we have to draw the time series on a graph. To draw the time series graph, draw x-axis and a graph paper, x-axis, y-axis. Where you need to do independent variable time is taken on the x-axis, independent, and y-axis, depending on the measured things. Plot the time values against the corresponding values, dependent on independent. I think you please see my video as well. I'm showing that. And based on this independent and the dependent, you call the time series graph or the histograms. Then depict the trend behavior. You will understand, right? In first year or in first month or first week, how it is. It's down. And it is again increased. Again, it is decreased. Again, increased. Or sometimes it is continuously increasing over a period of time. And then it came down. Right? This is simple. Freehand or graphic method. This is what generally, may not be the best example. In overs, in cricket, in every hours, like in every over 6 balls, every hours, how is the trend? First hour down, second hour high, third hour down. You will see those graphs there, simply plotting that. Right? There will be some estimation. This is to estimate the trend. There are some limitations as well. See this, years are there, lakhs are there. Okay, you draw this freehand graph. You keep the, where you need to keep in the years, x-axis or y-axis? Years on x-axis, lakhs on y-axis. Then only we can draw the graph, right? Simply. Semi-averages method also there. The data are divided into 2 parts. Yesterday, I think we discussed this. This is 2 parts. Semi-totals will be there. Semi-averages will be there. Semi-totals will be there. 2 parts. See, from first 3, 1 part, next 3, second part. And you got the semi-averages. And those 70 and 140 will be mid-year. We plot there. Here, semi-plots. Not continuously. Just you will put in the midpoints there. Plotted against the mid-year of the second part, 2016. The trend line can be shown in the graph. That is the thing. Okay, semi-averages. This is what. Semi-averages. Moving averages. 3-yearly moving. 9, 6, 10, 8, and it is decreasing, right? Decreasing again, it is increased. Again, it is decreased. Again, it is increased. How to the other 3-yearly moving total? Right? 9, 6, 8. This one, and 3-yearly moving total. You make this as 3 years. 6 plus 8, 12, 30, and the next one, next 3 years, 36. Okay. And next one, next 3 years, like this, next 3 years, next 3 years, next 3 years. You'll get these values. 3-year moving averages. Okay, average again. The 3-year moving averages is average. You take the average 10, 12, 14, 16, 18, and average 20, and average 22 by 3, by 3, by 3, by 3, by 3, by 3. This is the moving averages. And if the moving average is an even period moving average, the moving total and the moving average, which is placed at the center of the time span, which they have the computed, fall between 2 time periods. Okay. Applicable not only to the trend lines, but also all kinds of data that show regular periodic fluctuations. See this. Try to understand this. Moving averages, you got this, and you plot these years and these things, and you will get, the trend, how it is going, fluctuated down. This is, you draw on the graph, then you will get it. Okay. Now, this is called moving average method. How we taken the average? Hello? Have we taken this average? This first 3 total, I kept 30. Next 3 total, 36. Next 3 total, 42. Next 3 total, 48. Next 3 total, 54. Next 3 total, 60. Next 3 total, 66. And this 30 is for the 3 years, right? For what is the average? 30 by 3, 36 by 12. This is 3, 3, 3, 3. You'll get it. Yes, ma, is this clear?
Yes, sir.
The moving total and the moving average, which are placed at the center of the time span, from which they are computed, fall between the two time periods, like that. In between the center of the time period, you keep that thing. Now coming to the least square method. Moving averages method, least square method. Remember this, there are some other models also, but these two are more important things. See this, again, I'm just repeating what are there 4 models. Now, these things, keep it this point in your mind. Graphical method, you take the year or independent variable on x-axis, dependent variable on y-axis. Simple guy. Semi-average for every 2, if you have 6, you divide it into 2 or 3, then go there. Now, moving averages method for every 3 years, average, you find out the total 3. See, average means how you will calculate the average mean. Take 3 divided by 3 or take the sum of all these 3 divided by 3. Simple, right? See, that is what we are doing here. Directly we can make directly these values. Where are these things there? This one. 6 plus 8 plus 16 divided by 3 is equal to 10. That only it will come. Okay. 8 plus 16 plus 12 divided by 3. 12 will come. If you do like this, you will get this. Least square method, mostly widely used in the practice. It is a mathematical method. With its help, a trend line is fitted to the data in which a manner that the following 2 conditions are satisfied. Listen to this. This method, trend line, is fitted to the data. Trend line will come in, and in that trend line, we will try to understand. We'll try to understand how the trend is moving on. Let's see that. The sum of deviations of the actual values of y and the computed value of y is the 0, sum of deviations. How to calculate deviation? Deviations. That is, I have numbers 3, 5, 6. Let us say you known numbers 1, 2, 3, 4, 5. How to calculate the deviations for 1, 2, 3, 4, 5? X minus x bar, no, ma. Hello. Yes, no? Kalyan, no one is speaking.
Yes,
Yeah. X minus x bar. X bar is what? Yes, no? Average, right? Say, that is what? How the value is deviated from the mean value. Deviation means what? Let us say you have 9 members in the class. Kalyan have 10 marks and Kalyan having 10 marks, Abhiram having say, 1 second. Just 1 second. Okay, right. Okay, that is called deviation. When I take the marks of all your students, let us say Deepa, out of 100, she has 98, Abhiram having 99, Ganesh Reddy having 44 only, Kalyan is having 70, Pawan is having 80, Vijay having 90, Vishwant having 90. Now, if you say Pavani, she is having only 45, but the average is like how much? Let us say I got an average of 95. Are you all listening?
Yes, sir.
Yeah. When I take that average, and how much Pavani is deviated from the mean? She is having 45, mean is 95. How much it is deviated? Pavani, are you there?
About
Pavani,
40, sir.
yeah, above 40. But we can't include Pavani into more than 90%, right? See, the more it is deviated, the more. See, that is what we need to calculate. In the least square method also, this is called deviation. See, the average class marks are 90%. I declared like that. When I say average class percentage is 90%, but there are some values which are far away deviated from the mean value as well, right? That is the thing. That is why, of course, in some formulas, you will see the deviation. See, deviation is calculating like this. Take the mean, subtract the original value. Subtract, original value from the mean. You will get the deviations. That is the first step. Next one is least. That is the sum of the sum of squares of the deviations of the actual and computed values is least from this line. Hence the name method of least square. The line updated by this method is known as the line of the best fit. You take the squares of the deviations, you will get the least square. Okay, least square method. Okay. Now, if the straight line is fitted to the data, it will serve as a satisfactory trend. Perhaps the most accurate method of fitting is that of least square. This method is designed to accomplish two results. The sum of the vertical deviations from the straight line must be equal 0. See, again, vertical deviations. I'm now just only taking the deviation, the squares of the deviations. In that least, I am taking. In that least, the sum of the vertical deviation from the straight line must equal to the 0. When I take the vertical deviation plus 0, the sum of squares of all the deviation must be less than the sum of the squares for any other conceivable straight line. Okay. Now, let us see this. Any examples we have here? These are the merits and demerits of this. Considering the middle year as an origin, there are some other model to that. Now see this. This is the year. Sales are there. Sales we have taken. Deviations of the mid-year. This is the total N is equal to 7. And sum of Y is equal to 532. And the mean will be 532 divided by the 7. Some value will come. Mid-year. Deviation derived from the mid-year, that is 2014. See this 2014, 65 and minus the middle year, X, capital X, 65 minus the middle year. Then you will get these values. 65 minus 65 is 0. 65 minus, the 0. And then this is the sum. You will see this. Sum of Y divided by N is equal to 76. And when 76 we have taken, and sum of X into Y. Okay, taken the X into Y. If we calculate this one, we'll get the 136. And then square of the X square 28. You will get this point. The equation of the straight line YC. C denotes what? There are three things in the beginning we learned in the time series. Trend, secular trend, seasonal trend, cyclic trend, right? Hello? and you distribute, you keep the value in this a plus bx. Yeah, thank you, Vishnu. A plus bx. You keep the 76 here, a, and b value is this, and you will get this value. Forecasting of the sales for X 2020. If you take 2020, see we have 2017 here. 2020 will be, you take 2020 minus 2014. See this middle value I'm taking, plus 6 will come. When X is 6, then Y will be this. This is like sales for the year is 105.142 lakhs. Say, I have the data till 2017. I have calculated this. I got the sum value by N, and I got sum of X and Y, 136. Summation of X square is equal to 28. We got these values. 1 second. Okay, Emma, have you understood this? Excuse me? Yes, no? Shall I repeat this? You got this right? Year minus middle year?
Sir, it's all a bit clear, sir. But
Yeah.
we are recording the video, no? So we'll watch it again so that it is very clear. Because maths, no, we left it long time back. It's all statistics.
Then no one is listening now in the live?
No, they are listening, sir, but everyone is scared to give any answer. But we are recording, no? That's the reason. And we'll be saving all these recordings. And definitely we are using it for our assignments as well as we use it for our exam. Maths is little scary, sir. Statistics.
Okay, is this how many classes you attended, Deepa, till now?
Mostly I have attended, sir. Mostly I have listened to all your classes. But
is it? Okay.
Yeah, it is almost 30 years since I attended anything. I'm actually 53 years old.
Oh. Then I should
so
call
I
you.
want to keep myself occupied. I don't do the traditional things which people of my age do. So I'm studying and hopefully I can do a doctorate also. So this is a pre-final to a doctorate. If I can do this work, then maybe next 3 years also I can endure and put in a doctorate.
Then I should call you as Deepa. Yeah, then I should call you as Deepa ma'am now.
No, sir, no. I'm just a teacher actually.
Oh, that's great. Yeah, good.
Thank you, sir.
Right, madam. Okay, fine then. Right. So as Deepa ma'am said, okay, whether you respond or not, I will go in my way. But please try to focus live as well, because it will double the time. See, for the sake of joining,
always, sir, always I'm attending live. But find it little difficult to respond, so I keep quiet. Mostly I attend. But when I'm busy with family and other commitments, I don't attend, but I usually listen. I listen, and being a teacher, even I would want my students to respond to me. So but this is slightly difficult for me. Being just a mere English teacher, I find it slightly difficult to comprehend. But I'm focusing, sir. I'm focusing. I'm putting in a lot of hard work. Maybe I'm not showing any active response, but I guess I'll get at least that 40-50% in the exam and clear it.
That's fine.
Okay, sir.
Lily, what should you think? Okay, right, ma'am. Say this again, just let me repeat this. These are the years and sales in lakhs it has given in this. It is asking us to fit a straight line trend by the least square method to the following series. Estimate the value of the 2020. See, these are the values, sales, year sales are given. Now we are taking this straight line trend by the least square method. Okay. Yeah. Now, if the sum is given like this, whatever, it may be the 2020 or it may be 2025, 2030, based on the past data, we need to tell the estimated value of the sales in this year. How to do that? Say, this is what time series data, because we have years are there. What is the gap between 1 year to the another year? 1 year is there, 11, 12, 13, 14, 15, 16. Every year data is there. That is why sales is given. Now deviations, as I told you, the square of the deviations we need to calculate. And then we need to calculate the sales and the X value, XY, and the sum of the squares and sum of the XY. And you need to put it in this formula. Okay, let's try to check it. These are the sales. And deviation derived from the middle year. We know this mid year for the mid year is 2014. 2014, this is X minus middle year. This is the X. We can consider this as an X. 2011, middle year is 2014. 11 minus 14 minus 3, 12 minus 14 minus 2, 13 minus 14 minus 1. We know that this will come like this. Sum of X is equal to 0. Then X square is equal to these are the Y's. And sum of these X square is 28. XY is equal to this into this. We'll calculate minus 180 minus this one, X into Y. This is X, this is Y. 3 into 6, 18 minus 30, sum of X. Now, A, we know that we need to, Y is equal to A plus BX. That's the formula. Trend. Already we learned in the previous thing. The straight line formula is equal to A, Y is equal to A plus BX. See, this is the thing. Kind of, you heard about this equation, slope formula, right? Sum of Y divided by N, 786. And this is the Y, sales, and sum of XY, summation of XY into summation of X square least. And we will take this value, A got, B got. And when you got A and B, Y, X. X, we know that what is X here we have taken, we need to take it like, so for forecasting to the X will be what? 2000, Y is 2020 minus 24 is equal to plus 6, right? And when X is equal to 6, Y will be this. Very simple. 2020 minus 2014 plus 6 has come. And if you take this 2024 again, hello, 2024. Tell me the answer. What will be the sales for 2024? You calculate, you will get it. Same, 2024 minus 2014 is equal to some value will come, and you will get the X value and Y value will come. Based on this, you put all these values, any value you put, you will get this. 2020, you will get 2024, you will get 2026. Okay. Even number of the years, if you take odd number, if the numbers of years are odd, such as 5, 7, 9, then the middle year is the easy. But making deviation sum X is equal to 0. It is also easy. But when the numbers are years are even, see, because of the odd, 11, 12, 13, 14. But if it is even, we have, how many are there? 7. Mid value we have taken. When it is even is there, then what to do they? When the numbers are this, then there is no middle year, right? And in case of even numbers, years, take the origin from the midpoint or from the central point. That is, in case of 6 years, 3.5. In case of 8 years, 4.7. Then take the time deviations from that actual point and consider that as X. Okay, I think we have something. So we have here, right? 1, 2, 3, 4, 5, 6, 7, 8 are there. And how to take the mid? This is the middle year. In between divided by this sum, 2013.5. 2013.5 year minus middle year. Points will come. Very simple. This sum divided by 2 or mid value will get, right? This one. And this middle point you will get. Same thing, deviation square. X square will come. Deviation multiplied by 2. And X square came. XY will come. The same thing, AB values will come. Put it here, you will get the value. Conversion of trend equations. The following forecasting equation has been derived with series y is equal to a plus bx. Here is this. Rewrite the equation by shifting the origin to 2014, expressing x units in months, retaining y in years, expressing x units in the month. These are all the twisted sums. You just go through this, you will understand this. Basic we can understand. Okay. Now maybe in the next class, next Saturday, we will think about this block 4, probability. For some people, it will be easy. For some people, it may be tough, but easy to understand only. Just we will try to understand the probability basic things in the first unit, unit 12. And then after that, we will try to understand approaches to the probability here. And then after approaches, this is also some interesting thing. Maths is a thrill subject. Once you know one model, and if you take that particular another different model onto that, when you're getting the answers, when you're solving that, will be thrilled actually. See, calculations are the maths, but basically the models and the analysis part we call it as statistics. But in statistics, we'll use the mathematics. Okay, there are some theories are there. Developmental theories, probabilities, and Bayes theorem is there about understanding the probability. And then mathematical expectations will be there. Okay, permutations and the combinations, we know this already we learned in that, but we will try to understand what is permutations, what is combinations in first unit. And in the next unit, we will have discrete probability distribution for when we have the binomial distribution, when we have Poisson distribution, how to calculate the probabilities of that. The next unit will be about that is discrete series, binomial theorem, and every theorem will come. So bit, it will come with the practice. Maybe this weekend when we have the classes, maybe next week, if you have some time, at least just try to go through the notes. Notes are given very nicely and clearly. Okay, continuous probability. Here, normality, standard of normal distribution, standard normal cull, expected frequencies, 3 distributions, etc. It will be discussed here, this unit. The last unit is a bit easy to understand because already we discussed about the sampling things. What is sample size, and from what is that? Primary data and the secondary data, and the types of data collection methods in the second or third module, we learned it. This one, hypothesis testing, when we are testing the sampling, when we take how to take a hypothesis, what is hypothesis, what is two-tail hypothesis, how to calculate errors, and what are the tests that we have here to understand the hypothesis, and how to write. The last unit is very easy, how to write the interpretation in the data and the report writing. And with that, we will be finishing it. Okay. Yeah. Stop here. Maybe in the next Saturday, we will start with the probability. Okay. Have a nice day. Bye, everyone.
Thank you, sir.
Yeah, welcome.